Good morning, good afternoon, and good evening for whatever time it is that you're checking this. Today I will be explaining how conductivity works in different logic gates using truth tables. So the learning objectives are three main topics: understanding binary values, identifying common logic gates being AND, OR, NOT, NOR, and NAND, and to interpret truth tables for logic gates. So firstly, logic gates are basic components used in electronic circuits and digital systems, such as computers. They control whether electrical current is allowed to flow or not. In this explanation, conductivity refers to the flow of electricity through a circuit. A value of 1 means electricity flows, while a value of 0 means electricity does not flow. So going firstly with truth tables and binary values. To understand how logic gate works, we use these things called truth tables. Truth tables list all possible combinations of inputs and show the resulting output. Each input can only have two values, 0 or 1, which I mentioned before. 0 represents no electrical current and 1 presents the presence of electrical current. By looking at the output column of a truth table, we can tell when a circuit conducts electricity. So first, I'm going to be explaining the AND gate. This is the first logic gate. The AND gate requires all inputs to be conducting in order for the output to conduct electricity. When input A is 0 and input B is 0, the output is 0, meaning there is no conductivity. When one input is 1 and the other is 0, the output is still 0. This shows that even if one input does not conduct, the circuit remains off. Only when both input A and input B are 1 does the output become 1. This confirms the AND gate allows conductivity only when all inputs are on. As you can see, I have an example right here showing what I just explained. Secondly, for the OR gate, the next gate. Unlike the AND gate, the OR gate allows electricity to flow when at least one input is conducting. In the truth table, when both inputs are 0, the output is 0. And there is no conductivity. When either input A or input B is 1, the output becomes 1 and electricity flows. When both inputs are 1, the output remains 1. This shows that the OR gate supports conductivity as long as at least one input is active. The NOT gate. The NOT gate is different because it only has one input. Its main function is to reverse or invert the input value. When the input is 0, the output becomes 1, meaning electricity flows. When the input is 1, the output becomes 0, stopping the flow of electricity. The truth table clearly shows this opposite relationship. Because of this behavior, the NOT gate is also called an inverter. The NAND gate. The NAND gate is a combination of an AND gate also by a NOT gate. This means its output is the opposite of the AND gate. In this truth table, when both inputs are 1, the output becomes 0, so electricity does not flow. In all other cases, the output is 1. This shows that the NAND gate allows conductivity in most situations, except when all inputs are conducting at the same time. The NOR gate. The NOR gate is a combination of an OR gate followed by a NOT gate, so it produces the opposite output of an OR gate. When both inputs are 0, the output is 1, allowing electricity to flow. When either input is 1 or when both inputs are 1, the output becomes 0. This means the NOR gate only allows conductivity when there is no electrical current at the inputs. And lastly, I'm going to be explaining why this is all important. Truth tables are important because they allow us to clearly predict how a logic gate will behave before building a physical circuit. By understanding the relationship between inputs and outputs, engineers can design reliable electronic systems. These gates are used in calculators or computers or phones and many other digital devices. So, to conclude all of that, conductivity and logic gates can be easily understood using these truth tables that I explained. Each logic gate follows specific rules that determine when electricity flows or stops. AND, OR, NOT, NAND, and NOR gates each control conductivity in different ways, making them essential components in digital electronics. And that is it. Thank you so much. Enjoy your Christmas holidays.